Hello, welcome to CREATA CLASSES. I am Gurmeet Singh, and in this lecture we will cover the questions on surface area and volume of cone. Note that this lecture is part of the complete series on volume and surface area of various 3D solid. So let's begin the lecture. Our first question is, a joker's cap is in the form of a right circular cone of base radius 7 cm and height 24 cm. Find the area of the sheet required to make 10 such caps. Let's observe and visualize this question. This question is talking about a joker's cap which is in the form of a right circular cone, and the radius of the base is given as 7 cm. That is, R is given as 7 cm and height is given as 24 cm. That is, H is given as 24 cm. And we have to find the area of the sheet required to make 10 such cap. Okay, so basically first of all we will find the area of the sheet required to make one cap. Then we will multiply that area by the 10 to get the area of the sheet required for 10 caps. So first of all, let's find the area of the sheet required for one cap. What it will be? It will be the surface area of the curved portion of the cone. The surface area of the curved portion of the cone will be the sheet required to make this cone. And we know the surface area of the curved portion of the cone is pi RL. Radius is given as 7 cm, but L, that is the slant height, is missing. So how we will find the slant height? We will use the Pythagoras theorem. Here H and R are given, so we can write the slant height L as root of R square plus H square. Let's put the value. We got the slant height as 25 cm. Now we got all the three dimensions of the cone, that is R, H and L. Now we can find everything about this cone. Okay. Moving further, let's find the area of the curved portion, that is pi RL. Let's put the value of R and L. We got the surface area of the curved portion as 550 cm square. That is the area of the paper required to make one such cap. But in the question we have to find the total paper used for 10 cap. That will be equal to 10 into 550, that is 5500 cm square. That is the answer of the question. Okay. Let's move to the next question. The question is, the volume of a right circular cone is 9856 cm cube. If the diameter of the base is 28 cm, find first the height of the cone, second the slant height of the cone, third the curved surface area of the cone. Let's approach the question. This question is having the three part. The volume of a right circular cone is given as 9856 cm cube, and the diameter of the base of the cone is given as 28 cm. Diameter is 28 cm, means radius will be equal to half of the diameter, that is radius is given as 14 cm. And volume of this cone is given as 9856 cm cube, and formula of the volume of the cone is 1/3 of the volume of the cylinder. That is 1 by 3 pi r square h is equal to 9856. Okay. Here we know the radius as 14 cm. So let's put the value and let's find the height of this cone as 48 cm. Okay, we got the first portion of this question, that is height of the cone, as 48 cm. Let's move to the second part, that is the slant height of the cone. Here we know the H and R, that is height and radius of this cone. Can we apply the Pythagoras and find the slant height? So we got the slant height as root of H square plus R square. We know H and R, let's put the value. We got the slant height as 50 cm. We got the second part of this question. Let's take the third part, that is we have to calculate the curved surface area of the cone. Note that here the question is not talking about the complete surface area of the cone. The question is talking about only the curved surface area of the cone. And we have done the formula of the curved surface area of the cone, that is pi RL. We know the value of R and we know the value of L. Let's put the value in the formula. We got the curved surface area as 2200 cm square. That is the answer of the question. Okay. Let's move to next question. The question is, if S denotes the area of the curved surface of a right circular cone of height h and semi-vertical angle alpha, then S equals, okay, 4 choices are given. Let's approach this question. This question is talking about a right circular cone whose area of the curved surface is capital S. And the height of this right circular cone is given as h, and the semi-vertical angle means this angle, that is semi-vertical angle, is given as alpha. And we have to find the value of the area of the curved surface, that is capital S. Okay, let's approach this question. Here this angle is given as alpha, and we know this is a right angle triangle. This side it is h, and this is the slant height, and this is the radius. Can we write the radius as h of tan alpha? Okay, we have applied the trigonometry. Tan theta is perpendicular over base, so tan alpha will be equal to r over h. So we got r, that is radius of this cone, as h tan alpha. Got it? We got the r. Can we calculate the slant height L? L will be equal to root of h square plus r square, that is we have applied the Pythagoras theorem. Here let's replace r with h tan alpha. Okay, we got L as root of h square into 1 plus tan square alpha. And we know 1 plus tan square alpha is equal to sec square alpha. We have applied the trigonometric identity formula. Got it? Further, we got the slant height L as h sec alpha. So we got radius r as h tan alpha and L, that is the slant height, as h sec alpha. And we have to calculate the area of the curved surface, that is capital S, which will be equal to pi r L. So let's put the value of r and L. We got capital S is equal to pi h square sec alpha into tan alpha. That is the answer of the question. Got it? We got the answer of this question. Okay students, we have done with the right circular cone. In the next lecture, we will take down our next 3D solid, that is sphere and hemisphere. So that's for this video. Thank you very much and best of luck for the exam you are preparing for. Note that this is the series on volume and surface area of various 3D solid. So best of luck and have a great day. Bye for now.